Hi, hello, and welcome to the first video for section 3.3, parallel and perpendicular lines. Two different kinds of lines. Going to talk about each one. First, we'll talk about parallel, then we'll talk about perpendicular. We'll talk about what they are, making them, all that jazz. Visually, people usually recognize these. Parallel lines are like lanes in the road. They run the same. They never cross, is what people usually kind of go for as a visual reference. But that's not really what makes them parallel. Okay, that's something that happens because they're parallel. So chicken before the egg kind of thing. What's true about parallel lines is they have the same slope. They have the exact same slope. They have the same steepness. Remember, we were talking about slope in the last section, and that's what makes them never cross. If they're rising at the same rate, up or down, doesn't matter, they will never cross. They'll never have the same y-intercept. If they do, it's the exact same line, right? If you have the same everything, then you're just talking about the same line. But if they have the same slope, but different y-intercepts, different sets of points, different visual looks like you see on the page here, then those are parallel lines. Perpendicular lines, similar. People think of they cross at a 90-degree angle. That's a great visual representation, great geometrical representation, but it happens because of something with their slopes. They have as polar opposite slopes as you can get. Not only is it an opposite number, it's a reciprocal number. So, for example, the red line here has a slope of, I think actually, this is like 3/2. This picture doesn't apply to the slopes we're talking about. But the first line has a slope of like 3/2, and the second one has a slope of -2/3. Okay, so it flips over, causing it to be negative. And then the number also reciprocates as well. So if you had 2/3, it becomes 3/2. If you have 1/2, it becomes a whole 2, things like that. And that's what makes them perpendicular. All right, to determine that, you don't need to graph. You really don't have to graph anything. You just have to look at those slopes. And so if you kind of move away from the visual representation of parallel and perpendicular, this actually gets a lot easier. It's just another slope conversation. So we'll look at three different situations here, three different ways you could see these represented. We see lines that are given to us with 2 points. Okay, we don't need the whole equation here. We just need to determine if they're parallel, and to do that, we just need their slope. So let's look at the slope of the first line. Let's see. The y's have a distance of 5 to 1, which would be 4. The x's have a distance of 4 across 0 to -2, which would be 6. And that would be 2/3. Okay, so the first line has 2/3, which is great. Does the second one also have 2/3? Let's take a look. So from -2, and you know what? I'm just going to prove to you, it doesn't matter. -2 to 0 would be -2. From 0 to 3 would be -3. And yes, those double negatives cancel each other out. We see the same slope as the first one. So yes, they are parallel. And I usually use the parallel symbol. You don't have to, I'm just lazy. That's all it is. You can write parallel. For the life of me, I can't spell parallel ever, so I just use the symbol. All right, I recommend you try the second one on your own. I'm going to go ahead and do it real fast. And just to prove to you that you can, I'm going to do the points the other way. Because remember, it doesn't matter if I write it as 3, 6, and 4, 8. I could just as easily write it as 4, 8, and 3, 6, making my points, which one's first or second, unimportant, okay? Just have to make sure I go in the same way so I don't drop a negative or add a negative. Let's see, 6 minus 8, that would be a distance, that would be -2, or in total a distance of 2, over 3 minus 4, that would be -1. So this first one has a slope of 2. Over here, 2 minus 10 over 2 minus -2 minus -2. That'd be -8 over 4. That'd be -2. Now, some people, these are definitely not the same number, right? One is going up, one is going down. They are not parallel. Here's the thing, though. They're not perpendicular either. A lot of people will look at these and say they're perpendicular, right? They're opposites. No, they're not, bro. It's actually forming more of an X situation. Let me show you real fast on the Desmos calculator. So you've got, I'm regretting choosing this now. Let's see. You know what? I'll show you later with a set of perpendicular lines that have equations, because yeah, I'll show you later. All right, determine if the equations are parallel. Well, we just saw in the last section for a lot of different ways that you could determine slope. This first equation is already in slope-intercept form. If I turn it around, might be a little easier to see. We see that the slope is 3. So equation very convenient here for finding the slope. Second one, not as convenient. This is standard form, right? And standard form does not show us our slope, so we'll have to rearrange it. The fastest way to rearrange to find slope is probably to go into slope-intercept form. You could go into point-slope form, but that gets a little tricky to kind of choose your point with that. So I'll just go with slope-intercept form. Go ahead and move that 6x to the other side, and then divide 2 to everything. I get 3x plus 5 halves, and again I see that the slope is 3. Not a guarantee, but since they match, it's parallel. Parallel lines. Cool. Perpendicular. Let's check if it's perpendicular. For something to be perpendicular, they would have to have opposite reciprocal slopes. So let's take a look at these. Again, we're looking at the slope. Slope is slope. Slope's not going to change. So finding a slope, it's the distance, the steepness between 2 points. That's what we're looking at. So 6 minus 9 over 14 minus 2. You get negative 3 over 12. Reduce that a little bit. Negative 1/4. All right, cool. So that means it's going down 1 and over 4. For whatever line this is. Down 1 and over 4. Second set here. 6 to 2 would be a distance of 4. 8 to 7 would be a distance of 1. They're definitely not parallel, right? One's going up, one's going down. They are actually perpendicular. Notice how it's 4 over 1 and 1 over 4. Okay, so maybe even keeping it as a fraction might be a nicer way to tell. So we would say, yes, they are perpendicular. But even if they were reciprocal fractions, that's not enough. They also have to be negative as well. They have to be, opposite. One has to be negative, one has to be positive. If the original one was positive, the second one would have to be negative in order to be perpendicular. All right. Same situation here. We want to look at the slopes again. The reason we taught the 3 forms of slope first is so it'd be easier to use here. We see almost slope-intercept form here. Almost. Just have to divide that 2 out. This form that it's actually in currently, it's not a form. It's just a random halfway through the equation thing. It doesn't show you anything, so it's not really useful. It's mathematically fine, but it's not helpful in any way. Now it is. Now that I have divided out the 2 from everything, I see the slope is 3 halves. All right. Now we'll go over here. I'm going to switch colors so we can actually see this as a different problem. Sorry, I'm trying to make this video not super long. We've got 3y. This is standard form, right? And so the first thing I'd want to do is move this over. As mentioned, the fastest way to see slopes probably slope-intercept form from standard form, right? But you could do other things. You could mess around with this in other ways to find the slope. This is probably just the fastest. Y equals negative 2/3 x minus 2. The slope here is negative 2/3. And it is opposite and reciprocal. The fraction has been flipped over and the sign has been changed. And so we do have a set of perpendicular lines. All right, let's check this last one. I recommend you check it on your own. You could do this in several ways. Right now they're in standard form. I'm probably just going to go the way we've been doing. So negative y equals negative 4x plus 8. No such thing as negative y. That's negative 1y. So divide by negative 1, you get 4x minus 8. Over here, 4x plus y. Whoops, pardon me. We're just going to move that to the other side. Negative 4x plus 1. And here we see a slope of 4. Here we see a slope of negative 4. Not enough to be perpendicular. This was actually the one I wanted to show you on Desmos. This is the one I'm going to show you on Desmos. You might think, but they're opposites, right? I mean, they're not parallel. One's going up, one's going down. They can't be parallel. But how can they not be perpendicular? Let's take a look at it. So we've got y equals 4x minus 8 and y equals negative 4x. Y equals negative 4x plus 1. Oh, you little stinky. Sorry, having computer issues today. Equals negative 4x plus 1. There we go. Okay, now for these to be truly perpendicular, they have to form a 90-degree angle, right? A 90-degree angle should fall out of that. Look at these angles here. Those are not 90 degrees. You get more of an X shape. Okay, so when you've got something like that, if I throw in one that does minus, oops, is actually 1 over 4x, yeah, on the outside, come on, not irrational, we're not there yet, x plus 5, then what you see, this is a 90 degree. Do you see that? If you like turn the page a little bit, like I can't really turn the screen, but if you turn your head to the left a little bit, you see more of that 90-degree angle. So versus this, that is much more 90 degrees. And that is what enough, that's enough to actually be considered perpendicular. All right, cool. In the next video, we are going to actually find the equation of a line that is parallel or perpendicular. So we're not given both lines. We actually have to go find the other one. So I'll see you there.